morning to you all. This is Emmanuel Kadiri, the director of Emostel Academy and Emostel Skills and Development Limited. And tonight, I'm about to just take you through a journey, introducing you to some basic concepts of computer programming. And I feel very good to have you around here. And I believe that you're going to have a very wonderful moment with me. Please, if you have any question, make sure you ask. Feel very free to stop me at any time and ask any question based on what you don't get right. Don't manage to continue when you don't get anything clear. Please just call my attention to it, and I'll be very much willing to explain to you over and over until you understand. All right. All that you're going to learn tonight will help you in the subsequent classes that we are going to be having, so that you can be able to understand some things without me having to explain any further. So any terminology whatsoever that I use along the line of our practical coding classes, you'll be able to get along with them easily. So that is the essence of this theory, of this kind of class. So it exposes you to every terminology and every basic concept you need to understand about programming, so that by the time that we are actually performing the act of programming, you know exactly what is going on at every stage of it. So that is the essence of what you have today. All right, let's proceed. First and foremost, we are going to be talking about computer programs, although there are still some other things we talk about along the line, which includes algorithms, programming language, computer programming, and so on and so forth. But first, let's just talk about computer programs. Okay? Well, a computer program is a set of instructions given to a computer for it to perform certain tasks. Like you should know by now, every computer program, every computer system or every computer device, they need to receive instruction from you before they can do anything. They simply cannot do anything on their own except when they are instructed to do so. And so the kind of thing that we put up in order to pass this instruction to these computer devices or to these computer systems is what we call a program. In the real English sense, the word program can just be explained as a defined set of tasks or an arrangement or an ordered form of events, or a set of events that is arranged in order to make something happen. That is what we call a program. So the same thing a program means in your church is the same thing it means in parties, in wedding ceremony. It's the same thing it means in a seminar. It is also the same thing it means in computer. Program simply means some arrangement of events or arrangement of things that is structured in order to make something happen, or that is structured for some specified purpose. Do you understand? So that is what the program means. So as it means in a party, as it means in any other setting, that is also what it means in computer, because it involves we putting some things together in order to make something happen. And what is the thing that we want to happen? We want to give instruction to the computer so that the computer can perform some task for us. All right. So computers need to be programmed because they are not wise. They cannot think on their own. They are only smart. Being smart means that they can perform or carry out incredible tasks, some fantastic tasks. They can do millions of calculations within seconds, within microseconds, something that a human being cannot do. But it doesn't mean that they are wise. They are not wise. They can't do anything on their own. they have to be instructed. Do you understand? And so, because computers must be instructed, that is the reason why we have programs. Well, it is not only through some programming codes that we type with our fingers that we instruct the computers. We can also instruct the computers through the help of some kind of devices such as your keyboard, the enter key on your keyboard, such as your mouse. Whenever you click on a mouse, you're actually instructing the computer to do something. And then every mouse click has been pre-programmed in such a way that the moment the computer see the program, because by the time you click, the clicking is passing some program to the computer, some program that has been pre-designed. Okay, so the moment the computer receives the pre-program, it knows exactly what to do. It does what you ask it to do. And so whenever I'm talking about computer, I'm not just talking about your desktop or your laptop. I'm also talking about your smartphone. I'm talking about your smartwatches. I'm talking about your calculators and so on and so forth. All those electronic devices have a piece of central processing unit in them to receive instructions and execute them. Do you understand? And that makes them computers. In the real sense, what is the meaning of compute? To compute means to calculate. So it means to calculate or to work on some calculation. Do you understand? So a computer is simply an electronic device that performs calculations. It is these calculations that they do perform that make them to do the things you see them do. For instance, every time you type something on your keyboard, it is passing some electronic signals to the computer, to the CPU. You understand? And every time you click, it is passing some signals. Every time you even code and you are running the code, some signals are being passed to the CPU. And everything is going to the CPU in form of zeros and ones, which is the machine language. That is the only thing the computer understands, zeros and ones. So anything that is coming from the outside world needs to be translated to the zeros and ones, which goes to the computer as electronic signals, and then the computer picks them up, interprets them, and then carry out those tasks based on whatever signal it receives from those zeros and ones. It's just like your ear. As you are hearing something in your ear, okay, so your eardrum is beating, and your brain, the nerves that are connected to the eardrum, will interpret the beating of the signals, or will interpret the beating of the eardrums, and then send some signals to the brain, and then the brain will interpret the signal and then understand what you are hearing. That is the same way it works with a computer. So those zeros and ones send some kind of signals to the CPU, and the CPU will pick those signals, understand those signals, and work accordingly. And so because this signal come in form of numbers, zeros and ones, the computer dance to the tune by performing calculations on them. As it is performing those calculations, the result of the calculation is the output of the computer, is what you see that the computer do in return. So zeros and ones goes into the computer perform calculation on the zeros and ones and gives you result as output. So that is the reason why we call it a computer, because it performs calculations. It computes calculations. Okay, it calculates, it computes those numbers. It computes on those numbers, and that's why we call them computer. So whether it is your picture, whether it is the keystrokes on your keyboard, whether it is the click on the mouse, whether it is some anything, any signal that goes into the computer in any form, those signals are usually translated into numeric codes, into zeros and ones that your computer will receive, will work on, will compute. And that is the reason why we call it computer. It computes those zeros and ones, it computes those data signals, and then give you results as output. And so that's the reason why people define computer as an electronic device that accepts data as input, processes the data, and then gives you and then gives you information as output. Information is called processed data. Data that has been processed is what we call information. Okay, anyway, we are not going all that area. I believe you all know the definition of computer before. So let's just come back to the program. Okay, so I just try to make you understand the reason why computers are called computers. They are called computers because they perform calculations, and they perform calculations because everything that goes into the computer goes in form of numbers. Even though your picture, you snap your picture and you send it into the computer, or you snap with your phone, there are some things behind your phone that converts some things behind your camera that converts all these electronics, all these signals, which is like your picture, that converts the ray of light into digital signals, zeros and ones, that your computer receives and understands and works with. Okay, so that is the reason why everything that is saved in your memory card or is saved in your computer hard drive, they are saved in form of megabytes and bytes and megabytes and kilobytes and all that. The reason is that every 0 and 1 is called a bit. That is binary digits. BIT is a word formed from binary digits, so they are called bits. BIT. Okay, and a group of 8 bits is called 1 byte, and thousands of that 1000 of that 8 bits, that's 1024, gives you 1 kilobyte, and then 1024 kilobytes gives you 1 megabyte. 1000, so that's that. So all those bytes that you're mentioning, they are units of zeros and one fused together to form a single signal. Do you understand it now? So I think I'm going too deep. I'm going too far. I'm going away from the topic. So we might have to talk about all these things later. I might just create another theory class for it later. So let's come back to the class so that my 1 hour will remain 1 hour for the introduction. All right. So like I said, computers need to be programmed because they are not wise. They cannot think on their own, so they are only smart. Smart because they can carry out incredible tasks. All right. So then every computer system is designed to solve one problem or another. So it is then up to us to program them according to our needs. Your calculator is programmed to calculate. Your smartwatch is programmed to do what it's meant to do. It's designed to do what's meant to do. Your smartphones are designed to do what they are meant to do. Your laptops are designed to do what they are meant to do. So, but the thing is just that you need to just program them to be able to carry out their task the way you want them to carry it out, or whatever you want them to do for you. So a program simply tells the computer what to do. Now, a set of programming codes written for some specific purpose make up a software. So, which means whenever you write a set of codes, okay, when you write a set of codes for some specific purpose, those group of codes written for that particular purpose is called a software. Well, the real pronunciation of software is software. That is, the letter T is not pronounced. But see, we are in Africa, I beg, software. So, and then secondly is that software, when you have more than one software, you don't call it softwares. Software is software, it's singular and plural. That's all. Software is software, even in plural. So, then there are, therefore, a software is a packet of computer programs, which means like a software is made up of computer programs. Okay, computer programs written and they come together to form a single software. Computer programs written for some specific purpose come together to form a single software. Okay, so a software is like a packet of computer programs. So that's that aspect. That's just introducing you to what we mean by computer program. All right, talking about software, there are 3 different types of software. We have first the system software, which is we have the system software, which is like a foundation for every other software. Okay, so with the help of the system software, we have other software doing their job. Okay, so it's like the foundation upon which other software perform their functions or exist or do what they do. All right, the second thing is the utility software, which is actually concerned with everything that makes your computer to perform well, to function well. And then we have the third one, which is the application software. All right, so further explanation on system software. System software is designed to serve as platform for other software to work. They consist of files and programs that make up the computer's operating system. So they can access the computer's memory and serve as an intermediary between the application software and the computer's hardware. So the next topic I'm going to teach you after this, the next theory class that we are going to have after this is going to explain to you 5 units of a computer. So you really get to understand how computer work. So you need to understand all these things too. It's not just you coding. Okay, it's also essential for you to understand all those other fundamentals too. Okay, so but after this class, we go into a little bit of coding. We come back again to theory. We go back again to little bit of coding, and that's how we'll be switching on and on. So so system software is just like the grandfather or the foundation, the basic of every other software, and so it's upon the system software that other software perform their functions. Okay, and then also they can access the computer memory. It's because of this memory that I mentioned that I remember that I will still need to teach you something else again about 5 units of a computer, which is includes the input units, the memory units, the control units, the central processing units, which is made up of the control unit and the arithmetic logic units, and also the memory unit and all that. And then we have the output units too. So I'm going to explain all these units of a computer, which really will tell you how a computer truly works, how everything works together to make a computer do what they do. So we are going to talk about that later. But then the memory of a computer is a very important part of the computer. Just like you cannot function without your memory, without your brain, that is also how the computer cannot function without a memory. The computer is useless without memory. So memory is one of the most important part of the computer. And when we are talking about the memory units, we're not talking about the hard drive or the memory card or something. We are talking about the random access memory. And then we're also talking about some other important memories too, like the registers and all of those places like that. We are going to talk about everything in that time. So don't let me just digress too much. Then the next thing we talk about is the utility software. Okay, the utility software is designed to help analyze, configure, optimize, or even maintain your computer. All right, so any software that just makes your computer to be in good shape, that helps your computer to maintain a perfect shape, that kind of software is called the utility software. Examples are your antivirus software, the disk cleaners that helps you to clean your hard drive or your phone memory, to just make sure that it's working fine and it's not too overloaded, and that some useless things are not there, that wipes it off, some things that are not useful, it will help you to clean up and all that, just to make sure that your computer is working at top notch. So all this kind of software that helps your computer to perform their function in that way, makes your computer to work fine, that helps your computer to work fine, is what we call utility software. You understand? Your file managers, your compression tools like Zip, WinZip, WinRAR, and all that. So they are all examples. Okay, so then the next one is the application software. All right, the application software is designed to carry out specific tasks that benefit the computer user. All right, so examples are the Microsoft Office app, the game apps, the graphics app, the mobile app, and all that. The reason why we call them app is because they are application software. So any app that is installed on your device, either your phone or on your system, okay, to perform one task or the other, they are called application software. All right, now talking about application software, we want to really give other examples because they seem to be very important. In fact, they are the software that makes the computer make the computer to perform different things we see them perform. So whether it is graphics or whether it is game or whatever is it, we have different types of them. We have the game application, the graphics software, we have the presentation software like the one I'm using now, including examples are Microsoft PowerPoint, Google Slides, Easy Worship that you use in church, and all that. We have the multimedia software that helps you to play music and video and all that. So example, Boomplay, Spotify, YouTube, VLC, and so on. We have the web browser, the Microsoft Edge, Google Chrome, Firefox, Safari. We have word processors like your Microsoft Word, WordPad, Google Doc, and so on. We have the text editors, including Notepad, Sublime Text, Atom, and all that. We have spreadsheet software, Microsoft Excel, Google Sheets. We have live conferencing software like your Google Meet, the one I'm using now. We have Zoom, we have WebEx, and so on. And then we have different kind of software, different kind of application software for different purpose, and there are so many examples of them. So I'm giving you a task now. On your own, just go and get 5 more types of application software, and then give me examples like I just listed these ones. So I think I just gave you 1, 2, 3, 4, 5, 6, 7, 8, 9. So give me 5 more. There are a lot of them out there. You can Google them to just find out what they are. And so that's that as per that. So we've talked about computer programs. I think the next thing we are talking about now is algorithms. Well, algorithm, before we start bringing up the text, algorithm is just like a plan, a master plan for your computer program. So please, if you have any question, you can always raise your hand. If you have any question, you can raise your hand and I will answer you. So algorithms are simply like algorithm is a plan, like a master plan, a structured plan that is deliberately designed towards your computer program. It's just like you want to build a house, you need to draw the plan of that house and then hand over the plan to the builder so the builder can be able to work with the plan to build that house. You follow the plan to build the house. Imagine building a whole mansion without a plan. It is practically not possible. Like it doesn't make sense. That kind of house it's not as if you cannot build such a house, but the house will have no shape, no specific. It will even take you more time because you'll be having issues. You'll be thinking along the line, okay, what's the next thing I need to do and all that. So it's good to do all of that thinking far ahead before you start building the house. So that is the same thing as per a computer program. So it's good for you to. It's very good. It makes sense for you to plan your computer program before you start coding, before you start writing the code. So that's plan, that's well structured plan that gives you a step by step instruction on how to go about writing your computer program is what we call algorithm. In the process of your algorithm, you always consider so many factors, including the time it will take to write your code, the things your code is expected to do, the different aspect of your code, and how you want to accomplish the task you are given, and the we also consider the shortcuts or the shortest possible way of achieving any given task. All of those things are things you put into consideration when you are planning your program. That is when you are doing your algorithm. Okay, so algorithm is a well-defined set of step-by-step approach, or a kind of or you can simply put all of that English into one statement called structured plan. So an algorithm is a structured plan or a well-defined step-by-step approach designed or made up, okay, with an objective of being strictly followed to solve a problem or to carry out a computation. All right. So which means the central objective of an algorithm is that you should follow it to carry out a computation or you follow it to solve a problem. And what is the problem? We want to write a computer code. That is our problem. We want to solve a problem using computer code, using a programming code. And so you come up with an algorithm. So you follow the algorithm to solve that problem, or you follow the algorithm to write the computer program, and everything is fine. So it is a good programming practice to first plan your program before you start to code. So this plan, that particular plan that defines how your program would be developed is what we call algorithm. The master plan that defines how your program would be developed is what we call algorithms. And so that is how it works. Okay? Hello, hello. Please, are you still with me?
Yes.
All right, please. Sorry for the break.
Yes, we are.
Okay, all right, good. So it's a good programming practice to first plan your program before you start to code. Okay, good. So this plan, that particular plan, this plan that helps your program, that defines how your program will be developed is what we call algorithm. So coding algorithms may be represented in two ways, which are pseudocode and flowcharts. We have pseudocode and flowcharts. Well, pseudocode is a plain language description of steps of an algorithm. It's pseudocode is like, okay, let me give you an example. You want to cook rice, okay? Then the problem is to cook rice. So you need to draw out a plan to solve that problem. So number one, you write it like, okay, number one, get the rice. Number two, put a pot of water on the fire. Step number three, wash the rice and rinse it. Step number four, pour the rice into the pot of water and cover it. Step number five, add salt. Number six, cover the pots and allow it to cook for 20 minutes. And all of that. Those things you put down, those things you wrote, those steps you wrote because you want to follow the steps to solve the problem of cooking rice. Those steps is what we call pseudocode. Pseudocode is like a normal language, but it looks like a programming code. So it has a touch, a blend of some form of programming language, or let me call it, no, not programming language. It has some touch of programming syntax in it, okay? But then it is more of a normal plain English language description of what you want to do. All right. On the other hand, we have flowcharts. Flowchart is a picture, or like a pictorial representation of the things you want to achieve. And flowchart contains some kind of special shapes. Each of those shapes have what they do. Those shapes mean something. So it's part of the theory I'm still going to teach you later on, because we are going to treat algorithm as a topic on its own later on. Okay, and then I'm going to teach you pseudocode and flowchart, and how to use them to create algorithm which you will follow to write your computer program. So we are still going to talk about this much later. All right, so now the next page just shows you example of what pseudocode and flowchart means. Okay, so like these is pseudocode, like step number one, number two, number three to number eight, and this same thing that you have here is represented in flowcharts in a diagrammatic form. You see that the flowchart has different shapes. So these shapes have what they mean. They mean something. Okay, so when we learn algorithms, when I want to teach you algorithm as a topic, I'm going to explain the different shapes of a flowchart and what they represent. And so you are going to do it as you are going to practice it, and then I'm going to give you task which you practice and you get back to me with it. So that's that. All right. So we've finished talking about computer programs, we've talked about algorithms, and then let's quickly go into this new one called programming languages. All right. What are programming languages, or what is a programming language? Well, a programming language is a computer language used by programmers to instruct the computer to perform certain tasks. So, you know, if you call a small boy and you want to send the small boy on an errand, you need to give him instructions. You need to talk to him, and then he needs some memory to keep the instruction you gave him, and then he executes it. Okay? So, now, if you are speaking to this guy in a language he doesn't understand, then there is no way he's going to fulfill that task for you. So, which means that, or anyway, we are getting to that later on. But anyway, the point I'm just trying to make is that if you want to explain something to this boy, you must speak to him in a particular language. So the same thing happens to the computer too. We have learned that we must instruct the computer for the computer to do what it is meant to do. So therefore, that instruction you are giving to the computer must be given in a particular language. It must be given in some language. So the language with which you instruct the computer to do what it's meant to do, okay, is what we call a programming language. And those instructions is what we call program. You understand? The instructions are called program. Then the language that you use to write the program is what we call the programming language. You understand? And so that's how it works. So now the next thing is in a more technical sense that defining it more technically, we say a programming language is regarded as a set of rules or vocabulary which converts text or codes, okay, or in some cases graphical elements, convert everything into machine readable formats that the computer can understand and follow. All right. So when I'm saying graphical elements, sometimes you click on a picture and the computer will do something because you clicked on that picture. Okay, it's an example of graphical programming, and all that. So all of these things are stuff that you're going to know more about in the long run, okay, as we progress with this course. So all of these things must be converted into machine readable formats. When I say machine readable format, it means your machine is your computer, your electronic device. Your device is called machine. So when you hear the word machine, okay, we are talking about your laptop, we're talking about your phone or any electronic device, any computer device. It's called the machine. Okay, so specifically what I see that they call machine is the CPU, the processor, the central processing unit is logically what we call machine. Okay, so that is the thing that reads those instructions and executes them. All right. So which means in a more technical sense, it is regarded as a set of rules or vocabulary. And when you say a set of rules, every language have their own rules too. Okay, English language has its own rules, and you if you default the rule, then you will not pass the right message. You understand? So if I want to tell you you are an man, like, okay, the person will like, what is this guy trying to say? Instead of you to say you are a man. So because you broke a rule, it will not really make much sense to the person that is receiving it. Do you understand what I'm trying to say? So if you are a computer science student, there are some things, there is this particular course called formal language and automata theory. Formal language and automata. Well, if you are a computer science student, you would go through that course and all that. So you will understand what they mean by rules and vocabularies. Okay, but then I don't want to go too deep. But just understand that in a more technical sense, a programming language is regarded as a set of rules which converts text or codes. That is, it converts those things you typed into machine readable formats that the computer can understand and follow. Okay, so, and then popular examples of programming languages include Python, Java, C Sharp, C++, R, and so many of them. And so, programming languages are used to convert algorithms. That is, we just finished talking about algorithms. So we use programming languages to convert algorithms into programming codes. You understand? So it's just like your blocks. Your blocks are used to convert the plan into a whole building. Okay, that is the blocks, the building blocks. Okay, so those blocks are used to convert the plan that the architect wrote, the architect drew into a mansion. That is also how programming languages also help you to convert algorithms into programming codes. Okay, so simply speaking, they are used to implement algorithms. Okay, so programming languages are simply used to implement algorithms. So still talking about programming languages, so there are two broad categories of programming languages. We have the low-level language and we have the high-level programming language. Okay, so the low-level programming language We could call them low level because they are the first set of programming languages that came up. They are the first set of methodologies of instructing the computer on what to do. And they are also called low level because, well, a lot of people could not really cope with them, could not really roll with them, okay? Because they are not so detailed, they are not so comprehensive, they are not so powerful, like they are not so robust in functionality and also in comprehension. So they are not things that you can easily follow through or easily understand. They are much more close to codes that only the machine can understand better. Do you understand? We call them low level languages for all these basic reasons. Okay, so they are programming languages that provide little or no abstraction of programming concepts, and they are very close to the actual machine code. Machine codes are zeros and ones. Zeros and ones are what we call machine codes. Okay, they are binary codes. For those of you that did binary system in school, so and binary codes are just the only codes that your computer seems to understand. So whenever you write any other kind of code, they must be translated into binary codes for your system to know what they mean and then act accordingly. We are still going to that later on. Okay, so examples of low level languages are machine language and assembly language. All right, machine language and assembly language. Machine language is the very first programming language, very first programming language that is used to instruct the computer. It's made up of zeros and ones, binaries, and they are so difficult to undo. And because if you make any mistake somewhere, it will be so difficult for you to locate where the mistake came from. Imagine a stream of zeros and one, a large streams of zeros and one, and probably maybe where you're supposed to just put zero, you mistakenly put one, and then you can imagine, and then you need to debug. When you are debugging, like you are trying to locate where the error come from. That's what we call debugging. Locating your error in the program and correcting it. So it's so difficult to undo, so difficult to debug. So it now raised the necessity to develop another kind of language called the assembly language. The assembly language, in its own case, okay, this is how how the machine code looks like: a plethora of zeros and ones. This part here represents the inputs, I presume, and then this one is like the outputs on the extreme right, and then in between we have the code that represents these things. Okay, and this is how your machine code looks like, your machine, and this is what goes into your computer. This is what the computer understands. Every other thing you wrote in any other way has to be translated into this for your computer to understand it and work with it accordingly. You can imagine. And then this is the way assembly language looks like, the assembly code. So this is how it looks like. It's also it's also more like confusing, but it's still better. It still contains a whole lot of English than the machine code, which is made more of numbers, zeros and ones and all that. So this one is a combination of some short words and numbers and memory address locations and all that. So you don't need to go into this. Don't give yourself headache. You are not going to be needing them anyways. So, all right. Then the next one we talk about is the high level language. All right. The high level languages are these ones that we use today. Okay, they contain a lot of English, they contain a lot of things, they contain structures that you can easily understand. Even if you don't know anything about the programming language, you will still have an idea of what it's talking about whenever you visualize it. Okay, so these are programming languages that are regular human comprehensive, English like words, numbers, characters, and operators. Okay, they to represent code. They use all of these stuffs to represent code, so you can easily understand them. You can work with them. Although there are different kind of people, there are different kind of high-level programming languages out there: Java, Fortran, C++, C Sharp, a lot of them. Okay, there are a lot of high-level languages out there. Okay, and then different authors wrote them so that they can be used to program the computer. Okay, so all of them have the central purpose of trying to program the computer, trying to make the computer do one thing or the other. They all have that aim of doing that, but then they do it in different languages, in different forms. Okay, so the language that Java speaks is different from the language that C sharp speaks. If you want to say, if you want the computer to display something in Java, you will see something like sys dot out dot println, then in brackets whatever is it that you want it to display. If you want Python to do the same thing, you see Python will just say print and then open brackets and put what you want it to display there. So all of these languages have different ways that they use in performing whatever they perform or whatever they want the computer to do. Okay, different ways of instructing the computer. So they all speak the language. It's not like an Hausa man saying, if an Hausa man wants to say come, if an Hausa man wants to give instruction to a boy to come, he will say zo mana. Okay, if a Yoruba man wants to give the same instruction, he will say wambi by. If an Igbo man wants to say come, to give that same instruction, he will say bia neighbor. You understand? So all of them are trying to tell you to come, but in different ways. That is still the same way it is for the programming languages too. So we have different types of programming languages. We have Python, Java, C sharp, C++. You just have to learn each of them to be able to use them to instruct the computer. If you don't learn the language, you will not know how to use them to talk to the computer. So they are all languages. Python is a language, Java is a language, just like Hausa is a language, Igbo is a language, and you can use any language to instruct anyone. So the same way too, you can use any of these languages to instruct the computer to do what they do. The only thing is just that you have to learn them. You understand? So that you can be able to use them to perform, to instruct the computers accordingly. And so we have so most of the programming languages in use today are high-level languages. So this is an example of one of them, Python. All right, and so we move. Well, high-level languages are classified as procedural programming languages, functional programming language, scripting or script language. We have logic programming language. We have object-oriented programming language, and so on and so forth. Okay, we have all of them like that. So now we want to start first with the procedural programming language. You can see the example of how it looks like here on the right hand side of the screen. All right, but what is it about them? Why do we call them procedural programming language? Well, we call them procedural because it works with a specific order of arrangements. It's either run from up to down or run from down to up. And sometimes whenever you have a set of repeated activities, you can put those repeated activities into a form of function, or you can call it a subroutine. You can call it either a function or a subroutine. All right, repeated activities. Since, okay, for instance, if you are cooking, like the example I gave yesterday, if you are cooking food, something you do along the line of your cooking very often is to wash your hand. Okay, maybe you sprinkle some salt, you need to rinse your hand. You sprinkle some seasoning, you need to rinse your hand. You want to wash meat, you need to rinse your hand. You know, since hand rinsing is something that repeats itself along the process of cooking, then you may create a special subroutine for it and give it a name, so that at any time you want the computer program to carry out that particular task, which is often repeated, you only call that name. And when you call this function, okay, the computer exactly knows, it knows, because you will give each of the function a name. So whenever you call the function, it just goes to fetch the procedure and the process and then run the process for you. Instead of you having to code that repetition all the time, you can just give it only a single code and then give it a name. So you can always call that name each time it is needed along the line of your program, and your program will run as fine. Okay, so procedural programming language involves the use of code. It involves the use of code in a stepwise ordered manner to produce applications. I told you that it is orderly in manner. from up to down or from down to up. Okay.
Finally here.
Please, you can mute your mic. So it can run from down up to down or down to up and all that, and then it runs your code in a stepwise or ordered manner to produce applications or to produce software. You understand? So that's what procedural programming language does. So here, coding is done in an ordered approach, top to down or bottom up. Okay, special or repeated block of codes are made into functions or subroutines and are called when needed. I've explained this to you just earlier. So data are separated from function. So it's exactly 9 o'clock. It's exactly 9 o'clock, and we are supposed to switch into the second phase. All right, let's continue. All right, so some of the common types of programming languages used by scripts or software programmers are procedural. All right, I think a lot of them too follow this procedural approach anyway. So examples of programming languages that use the procedural approach in their systems are Java, Fortran, Pascal, Basic, and C. All of these programming languages, all of these high-level languages, they use procedural approach. All right. So we've just finished talking about procedural approach. The next thing we want to talk about is the functional approach, okay, or functional style, or paradigm, or methodology of high-level language. Okay. So the functional programming language, like the example you are seeing here, you see that it's basically designed. It's basically made up more of functions, function. So it is like a programming style that in which majority of the activities are performed using functions. Okay, so like a style of it's a different kind of style as against. It's not like the procedural programming, but this one is much more of functions. And then, in fact, there are some of them that are even mathematical functions that the computer will read, understand, and interpret and carry out tasks for you. Okay, so functional programming is just made up of functions entirely, function here. Although some other elements are also present in it. Okay, but principally made up of functions. Okay, in its approach. So this programming style involves the use of functions as the key driving force for the coding structure. In other words, it is the process of building software mainly with the use of functions rather than statements. So this implies that functions in this case are used to the best effect of creating clean and maintainable software. We are still repeating the same things in different ways just for you to understand. So the thing is that now function the guys they use, they do what they do. Bam. You understand? So and then they are characterized by properties such as immutability, referential transparency, recursion, and all of this. And I'm giving you this as your first assignment, the way I gave them in class yesterday. Go and find out the meaning of immutability, referential transparency, recursion, and all that. If you try to find out and you still have headache in the process or you don't really get it clear, then I will explain to you. So I want you to just carry out tasks of making the research of what do we really mean by immutability in computer programming, what do we really mean by referential transparency, what do we really mean by recursion, and all of these things. Okay. Anyway, there are things we are going to be dealing with along the line of your course, but then just try to find out what they mean. Take it as one of your tasks for today and come back to give me the feedback. If you need further explanation by then, I will explain to you with examples. All right, then we have other things here too. Programming languages that use this paradigm. The meaning of paradigm means style or methodology. So programming languages that use this style, examples of them are Scala, Erlang, Lisp. Lisp means list processing. We have ML, we have closure, all of these things. All these, they are examples of high-level languages that makes use of the functional approach. Although there are some other ones too, like Python, JavaScript, and so on. They also support it, but not majorly based on functional programming. Okay, so Python also supports Python, JavaScript, even Java also supports functional programming, but but it is not majorly based. It's just like a mixture of a little bit of procedural programming, a little bit of functional programming, a little bit of this and that is what makes them up. Okay, but the other examples I gave you earlier, like Haskell, Scala, and so on and so forth, those ones are just basically functional, like majorly functional in the approach. So other stuffs that they have is just a little bit, but it's majorly functional approach. Okay, so that's how it goes. Well, we have this other diagram here that just show you how the functional programming works and all that. We have the main function up there, then we have the sub functions, and the first sub function too. We still have some some grandchildren too. Okay, under the those. So it is just a build up of functions, function, and all of them will work together to carry out task. That's just how it is. So we have the pros and the cons of functional programming. Pro means the positive part of it. The cons means the negative part, that is the disadvantage. All right. So comprehensibility is one of the major advantage of functional programming. It's very comprehensive. When you read it, you will understand exactly what is going on. You will see the structure. You will see how they all work together to achieve some things. Concurrency too. They one thing after the other. They blend. Okay, they blend one after the other and all that. So we have okay video. So we have lazy evaluation, easier debugging and testing, and all of that. So those are the advantages of functional programming. Then the disadvantages are they are potentially poorer in performance. Okay, then it includes some kind of coding difficulties. It's not really as easy as others. There are no loops. Okay, so the fact that it doesn't have loops could be challenging, because there are some tasks that you really want to use loops. You want to perform with loops. You understand? So you sorry, someone is disturbing me here. Come on. So we have there are some tasks that you perform with loops. Loop means that you are repeating a set of operation over a number of times, okay, until a particular condition is met before the operation will stop. You are going to come across that too. It's one of the fun part, one of the most beautiful part of computer programming, which you are going to come across when I start teaching you Python and all that. Okay, so, but when it comes to functional programming, you really cannot use loops like that. You cannot even use loops. So the fact that you can't use loops could be so challenging. So you need to find your way around, another way of doing what you want to do in order to carry out the looping task. So it could be so challenging. So those are some disadvantages of functional programming, but then it has a whole lot of advantage. So whether you want to choose functional programming or procedural programming, any kind of programming approach you want to use, depends on the task that you want to achieve. It depends on what you want to achieve with your programming. So that is what really determines the kind of programming language you want to use. We understand it now, and the paradigm involved. Okay, so that is that. One of the things that really differentiates all these programming languages, apart from the language structure, is the paradigm. And that is also the reason why there are some jobs that you can best do with Python than with Java. There are some things that can best be done with Java than with C#. So, like for instance, now banks, they prefer, most banks in Nigeria use .NET. They use C#.NET to do their apps, their banking apps. And it's because C# has some functionalities that favor those procedures of banking, that favor the banking procedures, and that favor the design of the app or the banking procedures in general. Okay, if you want to go into data science, it is most preferred that you work with Python, because Python has provision for so many things that you do in data science. So the kind of programming language that you want to use for one thing or the other depends on the task you want to achieve, because they all have their strengths and their weaknesses. Okay, so moving forward, we have the next one, which is called the scripting language. All right, So the scripting language is like one of the most popular languages that we have today. Examples like Python and JavaScript and all. They are quite so easy to learn, so easy to understand. They don't have problems, and they are scripts. Like a scripting language is a script language, or a script language is a coding language that is used to manipulate, customize, and automate the facilities of an existing system. So the thing is that is why a language like JavaScript can almost not stand alone. It works with HTML and CSS. You understand? So if you want to learn JavaScript, for instance, now, it's just essential for you to learn HTML and CSS because it's like HTML and CSS give you it's like an existing structure, which you now use JavaScript to manipulate. Okay, in the old school when there was no JavaScript, if you want to if you want to you have some very boring websites, very boring and dull websites in 1990s, 1999, all those early era of websites. We have websites used to look very boring, but nowadays websites look very charming, very attractive, and very engaging. In fact, you can do a whole lot of things on some kind of websites. You can shop, you can do this, you can do that. So those extra things that you do on those websites are being inspired with the use of JavaScript. Many of them have been inspired with JavaScript. You understand? Because it gives that extra functionality. It makes something to jump up when you put a mouse over it. It makes some things to roll around. It makes shopping easy. It makes all of those kind of things like that. JavaScript help in putting life to your website. So which means that the website is already existing. The HTML and the CSS construct is already there. But you want the structure to do more. You want it to do more. So you impute the scripting language, which is JavaScript, and you use it to manipulate or to customize the website to do more things than the normal website that does not have JavaScript could ordinarily do. You understand it now? So one of the major function of scripting language is to manipulate stuffs. To you have an existing system, then you just bring them in to help you to further optimize the existing system or make it do some extra stuffs. Do you understand that? So that's one of the major functions of scripting languages. That's what they really do. You understand it now, big time. So they employ a high level construct to interpret and execute one command at a time. They are mostly not compiled. I'm going to explain the meaning of this compilation to you. I think that's what we are going to treat when we are done with all these programming methodologies. Okay, so we employ high-level language constructs. They employ high-level language construct to interpret and execute one command at a time. This thing that I told you here, we are going to explain it better when we go to language translators. Okay, so but then just understand that they have a mechanism inside of them. That is, scripting languages have mechanisms inside of them that helps them to translate every line of code one at a time, which means that the first line here is translated, the second line here is translated and executed, the third line is translated and executed, the fourth line is translated and executed, and that is how they work. Do you understand it now? So they are mostly interpreted and not compiled. I'm going to explain this to you later on. You understand it later. So they can be used to give instructions they can be used to give instructions to other software, such as web browser, your server, or even standalone application. You understand it now? So normal regular computer app, you can also use them. You can also initiate scripting languages to make them do some extra stuff. All right. So in general, they are easier to learn and faster to code than other constructive languages such as Java, C++, C, and so on and so forth. Okay, so if you have questions, please feel free to ask me at any time. We are going to 25 slides. We are on the 18th one. So many of today's most popular coding languages, such as JavaScript, PHP, Ruby, Python, and there are more of scripting languages. All right. So now the next thing is to compare scripting languages with the normal programming languages. All right. Well, a scripting language is platform specific. It is platform specific, which means that where it is specially designed for some specific platform. It is not cross-platform like you can have in for stuff like Java. Do you understand? So, because it is platform specific, it is limited to the platforms that it is designed to work with. So, if a particular scripting language is designed to work with is designed towards a particular platform, that is where it functions. Okay, so but programming language are platform agnostic, which means they can run cross-platform. Okay, a programming language that you wrote, maybe a Java language that you wrote on Windows. Okay, it can easily run on Mac. It can run on Mac without issues. Okay, you wrote it on Windows, it can also perform the same function on Mac without issues. But if a scripting language would do that, then there need to be some kind of intermediate platform that will help it to function. Okay, some virtual presence must be there. Okay, some virtual software must be there to help it to function the same way in the other platform. Do you get what I'm trying to say? So you learn more of these two along the line of your course. Well, scripting languages are lower, they are slower at runtime because of their pattern of execution. They execute line by line. Okay, but most other programming languages are faster at runtime. Faster at runtime because because they are more of compiled than being interpreted. I'm going to explain what compiling means and interpretation means later on. It's part of what you are learning today. Okay, so because most programming languages are being compiled, compilation means that after you have finished writing the whole code and you run the code, if you run the code, what it does is that it will compile all the old code. It will compile all the old code, put all the old codes, you understand, and then run it at once. Okay, during the compilation it checks for errors and all that too. So but when it is error free and everything is fine, then it runs the program. It runs at once. Okay, but but for scripting languages, because they work with interpreters, every line, one line at a time, is being translated. It's just like a church program that has a pastor preaching and somebody interpreting. You understand? So that service might take longer because that preaching might take longer because the pastor has to wait for the interpreter to finish talking each time he says a word or a statement before he moves on to another statement. Unlike a service that such is not happening and the service just goes straight. And because the service went straight, people that don't understand the language that the preacher used, the whole thing can now be altogether explained to the people and then for them to understand. So if you compare the two services together, you discover that they are one will be faster than the other because the other one does not include intermittent interpretation. Then the next thing is for scripting languages are less code intensive. That is, the codes are not so difficult and they are not so plenty to achieve some certain tasks that are needed. Okay, so unlike this one, which is programming languages, which are more code intensive, the codes are very dense, the code are very complex, and all that. Okay, for programming languages, if you compare C sharp or Java code with a Python code to achieve the same task, you will fear. You see that Python will achieve the same task in a very easy manner. You understand it now? And then C sharp will do it the other way around. Like C sharp will, like the same thing will be more complex, like a more complex construct to achieve the same task. You understand it now? So then scripting languages create apps as part of a stack, which means that you cannot use a scripting language to create a standalone app. You use them to create applications as part of a system, as part of an existing application. So which means if, for instance, you already have an application that can do one thing or the other, but you need some extra features, then you can use scripting language to trigger those features, to work out those features. You understand what I'm trying to say? And then, but you can use programming languages to create standalone application without any. You can use, for instance, Java to design a full app on its own that can do everything. But it is difficult for you to do that with Python or JavaScript. You understand it now? So, but if you have an existing system, you can use those scripting language to create some application that can work along with the existing system. You understand it now? Or that can do some other functionalities for the existing system. So then, scripting languages are mostly interpreted, like I have explained earlier, but programming languages are compiled. So those are the comparisons. There are differences between the two of them. All right. Now the next thing we talk about is logic programming. Logic programming. All right. Logic programming is used to program stuff like robots, like machines, all those machines that work in printing press, all those machines that work in factories, all those machines that you see do things. Majority of them, if not all of them, are programmed with logic. We use logic programming to instruct them. Do you understand? So logic programming, in its own case, is a programming paradigm or a programming style which is largely based on formal logic. You know what we call formal logic now? Many of you that did further mathematics in school, or many of you that did computer science, you understand what formal logic means. It contains facts and rules. It contains some facts and rules that you use to work with the facts. Okay, those facts must be correct. If the facts are correct, then things work. If it is not correct, then some things will not work. So it's based on that kind of stuff that we develop logic programming language. Do you understand? So, and then any program written in logic programming language is a set of sentences in logical form expressing facts and rules about some problem domain. Problem domain means problem arena, problem region. Okay. For instance, if I am meant to design an application for Jumia, then it means that the problem domain is e-commerce, because Jumia is based on selling stuffs online. That is e-commerce. Do you understand it now? So if I'm meant to design an application for Emostel Academy, then the problem domain is education. Okay, so that is EduSoft, software that is working for academics. Do you understand it now? Like this popular U-Lesson app and all of those things. So problem domain simply means the area of the problem that you are trying to solve. Okay, so what it does is that what the logic programming does is that it engages a set of sentences and in logical form, and that expresses facts and some rules about the problem domain. So if you check out the example on the screen, you will see what I'm trying to say over there. Okay, so for instance, if you want to code a fact, you can say food put it in burger in bracket burger, another food sandwich in bracket, food pizza in bracket. All right. So the meaning of this thing you put in brackets, like food and bracket burger, the English meaning of it means burger is a food. Food and brackets sandwich means sandwich is a food. Food brackets pizza means in normal English it means pizza is a food. Lunch into brackets sandwich means sandwich is a lunch. Dinner in bracket pizza means pizza is a dinner. So that's how you code in that language. Okay, it's more of some kind of logical arrangement of facts. Okay, and then that the rules with which this fact works, you establish those rules. Okay, so if you say meal X and then you put this column and hyphen and you put food X, what it really means in normal English means every food is a meal. Okay, or anything is a meal if it's a food. So all of these things are you are not learning it now anyway. So I'm just like trying to paint the picture, paint the ideology of logic programming, how it looks like, how it works. Okay, these are just regular examples, but it's more complex than this. Do you understand? But this example just brings life, just gives it life, just helps you to reference how the thing really works for real. Okay, and so, but you are not learning it now anyway. We move on to the next 10 points that says this programming paradigm can be applied in natural language processing, NLP, data management, and even predictive analysis. So, common examples of logic programming languages are Prolog, you understand, answer set programming, that is ASP, and then we have data log and so on and so forth. So we've talked about all those programming paradigms. The next thing we need to talk about now is computer programming, which is like the last part of our class today. Well, computer programming is an act of coding. That is, computer programming is a process of coding. It's an act of coding. So each line of code is aimed at instructing the computer to carry out certain tasks or simply do certain things. So I've explained all of that to you earlier. So the only language that the computer understands is the machine language. The only language the computer understands is the machine language. Machine language is formed from the binary alphabet 0 and 1 only. I've explained all of these things to you earlier too. So as you pass your instructions to the computer, it must be made in some certain language. That is, those instructions must be made in some certain language. Like I've explained this one too to you earlier. Okay, so the language is called the programming language. So as discussed earlier, there are several programming languages available today, most of which are high-level languages. And then whatever we type in our line of code using these programming languages must therefore be translated into what the computer directly understands or can assimilate. Hence, the need for language translators. So what I'm trying to say is that any line of code that you write, okay, any line of code that you write during your programming, okay, so those code must be translated to things that the computer can understand, because the only thing your computer understands, for God's sake, the only thing you understand is zero and one. So anything apart from that, the computer is not really getting it clear. It's not really getting it. And you need to communicate with this computer. You need to speak to the computer. You need to pass instructions to the computer for the computer to do for you. So because instructions need to be passed to the computer in a format that the computer understands, that is the reason why we need what we call language translators. As a matter of fact, these translators too, they work in the reverse manner, which means whatever is coming from the computer to you comes in form of numbers too. So the translator will translate it into what you can also understand. And that's the reason why we can see what you are seeing on the screen. Okay? All these things that you are seeing on the screen is different from what the computer is passing to you. The computer is passing zeros and ones to you. But something has done the job of translating the computer stuff into what you can understand. And that's the reason why you can flow with what you can get the detail of what you're seeing on the screen. You understand? So now we have the language translators. Please hold on for me. All right, it's connected. All right, sorry. So we have the language translators, which helps us to translate or interpret, or you know what we are trying to do, what the code that we are trying to write, or that we are writing rather, or we wrote the code that we wrote into what the computer can understand and then execute. Okay, so now talking about these language translators, we have three types. We have the assembler, we have the interpreter, and then we have the compiler. Talking about language translators, we have the assembler, we have the interpreter, and then we have the compiler. These are three language translators that we have. Well, the assembler translates codes written in assembly language into machine language or into something that the computer can understand. You know, I told you before that we have low-level languages. Example is assembly language and the machine language. They are low-level language, and then we have the high-level language, which is the thing that we've been talking about since. Okay, so the assembler works with assembly language alone, which means that if I write a computer code, if I write a programming code in assembly language, the job of the assembler is to translate the code I wrote into machine language so that the code can be understood and be executed by the computer. All right, so that is that as per that. Then the next one is the interpreter. What does the interpreter do? The interpreter directly executes source code written in some high-level language, okay? Which means that every line of the code, the job of the interpreter is to directly execute each of the line, okay? It comes into the system to interpret each of the line of code and execute it immediately. So line 1, it reads line 1 and executes it. It reads line 2, executes it. It reads line 3, executes it instantly. That is what an interpreter does. Okay? So all these scripting languages work with interpreters. Interpreter is what they basically use, okay, in scripting languages. And that is why they are rather a bit slow in their execution. Although they are fast in their passing, or when you want to analyze them, they're very, very fast in analyzing, but slow in execution, because you have to wait for a particular line to be run before it goes to the next one. Unlike compiler, which will wait for you to finish all your coding, and then it will just bring everything together, work on everything together as a whole, and then execute it. Okay, so the process of bringing everything together might take time, but the process of running or of executing the instruction is very fast. But for interpreter, the process of putting everything together is very, very fast, but the process of execution is rather slow compared to that of compiler. Do you understand it now? So like I explained to you earlier, that when you have a sermon that is being interpreted, the sermon may take longer than a sermon that is not interpreted, that the pastor will just be talking straight. When the pastor talks straight, and then all the things that the pastor finish saying, somebody just comes to the stage and interprets and then explains everything to the people. You see that one is faster than the pastor will talk, someone will interpret, the pastor talks, someone interprets, the pastor talks, someone interprets. So it can be slow, but in terms of analysis, yes, it is fast for analysis, because as the pastor is talking, the interpreter is interpreting instantly. So it's not taking much time for the listener to get what the pastor is saying. So the analysis is very fast and very intact, but the execution is slow, which means the overall execution is somehow slow. We are coming to all of that anyway. So interpreter directly executes source code that is written in high-level language. So if it doesn't do that, another thing an interpreter does is that it translates the code into a lower language and then executes it immediately. That's another way it works. It either executes the code instantly without translating it to anything, or it first breaks it down. It's just like your digestive system. When you take in fruits, your fruit does not have to go through digestion. Your fruits go straight into your bloodstream. For those of you that understand biology, if you drink orange, orange does not pass through digestion, okay, because the molecules are very, very tiny. The molecules of the orange juice is very tiny, and it can easily penetrate through your small intestine to enter into the bloodstream. Okay, but if you eat eba, if you eat solid food, that one needs to digest, which means it needs to be broken down first before it is now assimilated into your body system. That is also how the interpreter works. The interpreter can either directly run your code, it can run your code instantly, and then you see the results. Okay, or another thing it does is that it translates each line of the code, it translates them into a lower language, okay, and then executes it immediately. The lower language is usually the language close to machine language that can be run easily by the machine. Do you understand it now? So, and whatever it does, whether it directly executes each line or it translates into a lower code and then executes it instantly, whatever it does, okay, it always does them one instruction line at a time. It does them one instruction line at a time, okay. So that's that as per that for interpreter. Then what about compiler? Compiler translates an entire source code. That is when you finish writing your computer program, it will translate the whole source code, the whole written code, okay, written in some high level language. It will translate everything to a target language that can then be read and executed by the target machine. All right. So which means the work of a compiler is that it translates the whole code that you wrote. Maybe you wrote a program in Java. It translates the whole of the Java code into a particular target language, which is called the object code or the target code. All right. And when it finished doing that, that code is easy for the computer to understand. And then what the computer does is the computer now understands it, it reads it, and executes it. All right. So stage one is that it compiles all the old code that you wrote and converts it into what? Stage one is that it compiles the code. Stage two that is converts the code into an intermediate code or an object code or a target code or a target language. All right. Now the reason why we are using the word target language is that compilers don't only helps you to convert your code into what the computer can understand. It also helps you to convert one code written in one language. It converts one language to another language. So that is the reason why the word target language is used to generalize it. It doesn't only convert to machine language, it can also convert to another language, depending on the kind of compiler it is. So which means that if you want your program that you wrote in Java to be presented to the computer as an assembly language, no problem. You need to just get an assembly language an assembly language compiler, which will help you to translate your high-level language into an assembly language for you. So which means I'm just trying to generally explain to you that languages can be translated from one form to another with the help of compiler. But in this case, we are only targeting the aspects where your compiler translates your source code written in one high-level language into an intermediate code or into an object code, okay, that your computer can understand. So because it can understand it, it reads it and executes it for you. Do you understand it now? So that is the work of a compiler. Translates a code in high-level language into a machine language that the machine can easily work with, read and execute. You understand? So that's that as per that. So well, the assembler only works with the code written in assembly language, like I said before, and the interpreter and compiler work with high-level languages only. So interpreter and compiler work with high-level language, while assembler work with only assembly language. And then the language translators themselves, all these translators that we are talking about, all of them too, they are themselves also computer software. They are software too. All this language, like whether it's assembler or interpreter or compiler, they are also software. They are also software, but specially designed for what they do. Okay, so they are also special software that is specially written, specially designed to do the things that they have been described to do. So they are also part of system software. You know, when we started too, I told you different kind of software that we have and all that. So now it's time to just compare the two of them. We want to compare interpreter, okay, and then compiler. But let's start. Well, as for the interpreter translates only one line of code at a time. It takes less time to analyze or check through the source code. So, which means the interpreter analyzes the source code very fast. It checks the source code very fast and detects error very fast. Okay, because it checks them line by line. Okay, so and then the interpreter also takes longer time to run. That is, it takes shorter time to analyze your code, but it takes longer time to run or to execute the overall program due to its mode of operation. Okay, then the interpreter stops processing the code once it detects an error. Hence, it makes debugging to be easier. That is, where your interpreter is reading every line of your code and it comes across an error, it will stop there. Those of you that attended the Python class, the introductory Python class with me 2 months ago, you notice that anytime we make a mistake in a particular line of code, the code will stop running at that point and it will point out that mistake for you before it begins to check the next thing. It will check through your code from beginning. You check through. When it gets to the point of error, it stops there. The program will terminate in that place and it will point out that error for you so that you can correct the error and then run the program again. Do you understand? But for a compiler will check the whole of the program and pack all the errors together and list all the errors for you. So you will now start checking for them one by one to correct them. So in that case, it makes it a bit, uneasy to debug. Debugging means you are checking your code for error and you are correcting the error. That's the meaning of debugging. So the story of bug and no bug. Bug is error. Debugging means removing the error. So this story of bug is a very funny story. In the olden days, computers used to be very big, and the engine, you will see the engine is very heavy and they always have to put air conditioning system in that room so that it can be cooling the engines. The engines are very big and the computers are very big, but they are so slow despite how big they are. Look at irony of life. And we have portable computers now that are very, very fast, thousands of times faster than the old computers that are big and heavy. So now they said, according to what I heard, the story that I heard says that the story mentioned that there was one day that a small bug, entered the engine, and because the engine is made of electricity, so the thing got electrocuted, and it died in that engine, but it affected the working of the computer. So they had to call engineers to come and remove the bug and clean the computer so that the computer can work perfectly. So that cleaning of removing the bug is called debugging. So the story of error and error and error started from that place. So because the thing caused some error in the computer functionality when the bug died in the engine. So that is where that's where the name came from. So nowadays, anytime we have a problem, although we cannot have a bug entering our computer, and if you do have them, they don't die there, they flex. But however the case may be, what we call bug nowadays means the error in your code, and then removing those errors is what we call debugging. So, well, let's move on. The interpreter does not generate any intermediate code, therefore it's memory efficient. That is, it does not require much memory for execution. Okay, unlike the other one, which because it will first convert the code from one code to another code and store it inside the temporary memory. Then the computer will now go there and fetch that instruction and work on it. So, but this one does not need that kind of extra memory because it doesn't translate from one code to another code. It just works on the code and interprets it and executes it immediately. You understand? So examples of programming language where you can find the interpreter is Java, C Sharp, C++. You can find interpreter there. You can also find interpreter in Python. I don't know why I did not include Python there. You can find interpreter in Python. You understand it now. So although Java also contains compiler too, In fact, all these examples I listed, they are mainly compiled than interpreted. I think I'm going to do adjustments. I'm going to do necessary corrections afterwards. You understand? So let's check for compiler. Um, and then I told you that Java 2 can. So most of all these things, all these programming languages, they have both compiler and interpreter inside of them. So it just both of them work simultaneously depending on what you are trying to achieve. But Java, C Sharp, and all this, they are mainly made up of mainly of compiler. Python is mainly of interpreter. JavaScript mainly of interpreter. So I'm going to do some correction in these examples, please. All right, so compilers translate the entire program into machine code at once. Okay, it takes more time to analyze the source code, unlike what we have here. And then, however, its overall execution time is less because once the code becomes fully analyzed, then the thing is just the compilation is very, very fast. I mean, the execution is very, very fast after it has analyzed the code. Now, this one shows all errors after the compilation process. Hence, debugging is more difficult. This one shows one error at a time. This one shows all the errors together. So, for compiler generates intermediate code. So, therefore, it often requires sufficient memory for execution. You understand it now because it generates code and the code needs to be stored in a temporary memory so that the CPU can go there and fetch the simple code for execution because the code is speaking the language it understands. So generally scripting languages, for example, I put them for one another. This thing that you have here on the left hand is supposed to be on the right. What you have here is supposed to be here. I'm going to correct it and send it back to you. Okay. Oh, my battery is running low. All right. Anyways, that is the end of the class. I'm going to make that correction, please. All right. The examples that I have listed here are for scripting, for interpreter, while the examples I have under the interpreter are for compiler. So please take notes. All right. And, well, ladies and gentlemen, this is the end of the class. Thank you for joining the class. And thank you for being a part of our success story at Emostel Academy. Please feel free to ask questions. Make use of the slides that I'm going to provide the slide at the end of the class. Drop it inside the WhatsApp group. And then you can have them for you to study. If you have any questions, please feel free to ask. And if you don't have any questions, I'm going to give you some assignments in the WhatsApp group. So please make sure you follow those assignments very well. Okay. And then that is that as per that.